Close your eyes for a second. Imagine, billions of years, the grandest cosmic construction site, supernova explosions, clouds of gas and dust the size of galaxies, gravity squeezing, tearing, shaping, an unimaginable, deafening chaos of birth, collisions, absorptions, planets forming from debris, crashing together, changing orbits. Do you think all of this is just chance? A simple game of cosmic roulette, played out over an eternity, chaotic spinning around a young, furious sun. And now, look at this. Look closely at this system, at these orbits, at these distances. All the planets in the solar system are arranged according to a pattern, astonishingly precise, incredibly regular, far too ordered for it to be merely the result of billions of years of aimless chaos. This isn't chance. This looks like a design. In the 18th century, there lived a man named Johann Daniel Titius, a professor of philosophy. He noticed something peculiar about the distances between the planets, and he devised a formula, a simple sequence of numbers, each subsequent number roughly twice the previous one. He shared it with another astronomer, Johann Bode, who gave it a more precise form. They took this numerical sequence and attempted to apply it to the planets known at the time: Mercury, Venus, Earth, Mars, Jupiter, Saturn. They adjusted the scale, and they arrived at numbers that match the actual distances of the planets from the Sun with startling accuracy. The scientific community largely shrugged. An interesting coincidence, perhaps, but likely just numerology. However, the formula predicted something more. It left an empty space between Mars and Jupiter, a void where, according to the logic of this pattern, a planet should have been. And scientists began to look. And they found something. Not a single planet, but an asteroid belt. And within that belt, Ceres, a dwarf planet. And do you know where it was found? Precisely where this nonsense formula had predicted. Coincidence? Perhaps. A bit of a forced pattern that just happened to work out a couple of times? Possibly. But why can these distances even be expressed through a geometric progression? Through a simple, repeating mathematical template? As if someone took a ruler, or perhaps a logarithmic scale, and placed the planets according to the markings. This isn't just a planet is here and another is there. It's a planet at this mark and the next one is at the next mark, which is a multiple of the previous one according to a clear rule. Why does the cosmos behave like a carefully ruled sheet of paper? Why did gravitational interaction, explosions, collisions, billions of years of random processes, why did all of this lead to a structure that can be described by a simple school formula, an uncomfortable precision? The first whisper of order in what seemed like chaos. If the distances are suspiciously precise, then what about the movement itself? The planets don't just orbit, they create a rhythm. Each has its own period of revolution around the Sun, its own frequency. And if you listen to this cosmic orchestra, you won't just hear disparate notes, you'll hear harmony. The most famous example, Jupiter and Saturn, the two giants. When Jupiter completes exactly 5 orbits around the Sun, Saturn completes exactly 2 in the same time. It's not roughly 5 to 2, it is precisely 5 to 2. This is called orbital resonance, but that's not the only instance. Neptune and Pluto are in a 3 to 2 resonance. Throughout the solar system, we find many such clear integer ratios, as if someone hasn't just sent spheres hurtling around, but has tuned a set of tuning forks. These numbers, 5 to 2, 3 to 2, and others, aren't random. In music theory, these are intervals, perfectly consonant. Why would the mechanical movement of giant bodies obey rules we use to create harmony? This isn't just gravitational interaction. This is interaction that leads to mathematically ideal frequency ratios. What if the entire solar system isn't the result of chaotic gravitational perturbations, but a mechanism operating at specific tuned frequencies, like giant cogwheels in cosmic clockwork, fitted together with astonishing precision, so their rotation creates a specific melody? This isn't chaos giving rise to order. This is order that sounds like music, as if the very structure of space-time in this location resonates on certain wavelengths. Now let's look at other peculiarities. Think about billions of years of chaos, collisions, gravitational pulls from passing stars, gravitational dances that could fling a planet out of orbit or drastically alter its rotational axis. What would you expect? Planets flying in all different directions, in orbits tilted at every conceivable angle to the sun, some perhaps spinning backwards, wildly eccentric, elongated orbits, jumping and changing shape over time. And what do we actually see? All the planets, save for perhaps Pluto, which is no longer considered a proper planet and whose odd orbit only serves to highlight the rule, lie almost on the same plane, the ecliptic. Not just roughly there, they lie on a single, invisible tabletop, like pucks on a perfect billiards table. All of them orbit the sun in the same direction, as if caught by one giant, perfectly smooth current. Their axes aren't tilted haphazardly, but within a specific, relatively small range, with the exception of Uranus, which lies on its side, again, a rare exception, proving the general rule. Their rotation around their own axis is also, for the most part, in the same direction. Why? Why in a system that formed in a swirling cauldron of chaos did everything end up so aligned, so unified? Where are all these jumping orbits? Where are the planets that should have been flung into interstellar space or fallen into the sun over billions of years of gravitational perturbations? They should have been there by all the laws of chaotic dynamics, but they are not. Perhaps it's because you're looking at a system that doesn't tolerate chaos, at a pattern from which all the errors have already been removed. Perhaps unstable orbits did exist, but they were tidied away, not necessarily by hands, of course, but by some force, some principle that aligned the system, discarded the debris, and left only the ideal, stable elements, as if this system has a built-in self-correction mechanism, or someone was fine-tuning it. This is where we arrive at the most unsettling question. If this is a pattern, if it's a tuned mechanism, if it looks like architecture, who or what could have created it? Again, let's dismiss the image of little green men with spanners building orbits straight away. That's far too simplistic. But can we entertain the idea that the solar system isn't simply the passive result of blind forces, but rather an engineered object? Not in the literal sense of someone built it from bricks, but in the sense that it's the result of the application of information, the application of structure, something that imposed form upon the chaos. In modern physics, there are ideas that go far beyond our everyday understanding. Some scientists, like Eric Verlinde, propose that gravity isn't a fundamental force in the usual sense, that it's more like an entropic or informational phenomenon, that the very fabric of reality at its deepest level isn't particles and fields, but information, a code. And gravity, like other physical laws, is a consequence of processing this information. If that's the case, if reality is built on an informational foundation, then what if the orbits, The resonances, the distances, the alignment. These aren't just the consequence of physical laws, but a manifestation of this underlying information. Traces of a program running beneath the surface of visible physics. This isn't a metaphor. This is one possible layer of reality being explored at the very cutting edge of science. What if the solar system is simply the most stable, the most debugged configuration of this program? Not chaos that happened to stumble upon order, but a structure that imposes order, filtering out everything that doesn't conform to it, like a crystal forming from a solution because it's programmed to do so in its molecular structure. Only here, the molecules are planets, and the structure is the informational code of the cosmos. Look at the system again. With this new perspective, clear your mind of the idea of a random explosion. Dismiss the thought of billions of years of haphazard drifting. At the center, a source of energy. Around it, bodies that orbit with a precision that would be the envy of any Swiss watchmaker. Ratios of distances expressed by geometry. Ratios of rhythms sounding like music. A perfect plane. A single direction of motion. The absence of chaos where you'd expect it most. All of it bears a striking resemblance to architecture, to a complex functional structure, not just a collection of rocks and gas, but something that obeys deep, perhaps non-obvious rules. Perhaps our solar system isn't merely a random house we've found ourselves in. Perhaps it's something far more extraordinary. Perhaps it's a signal, tuned to a specific frequency. The frequency of the observer, tuned to you. Sounds like science fiction? Yes, but it's born from the most real, the most peculiar facts about how our cosmic neighborhood is arranged. The Titius-Bode formula, orbital resonances, unexplained structural regularity. This isn't make-believe. It's what we see when we look up at the sky. And if that's true, if our home isn't just a random clump of matter, but part of some grander, more meaningful structure, then what lies beyond these aligned orbits? What is hidden beneath this perfectly tuned mechanism? What if this is just the first level, the visible interface of something immeasurably more complex and astonishing? The world seems suspiciously ordered now, doesn't it? As if you've just noticed the fine strings pulling the puppets. If you're curious about what force or principle lies behind this cosmic architecture, if you want to discover what else we might find when we start looking not for chaos, but for the pattern, subscribe to the channel, because from here, things only get stranger and far more interesting.